Uh, uh, okay, recording. So once again, it's my pleasure to introduce Niyati Bafna today. Um, Niyati was a student in our LCT study program, in the master study program, and actually she spent her first year in Prague in the worst COVID times, I would say. So we hadn't much opportunity to meet her in person at UFAL, and then she spent her second year in Saarbrücken, and currently Niyati is a member of INRIA in Paris. I'm also happy to say that Niyati was remarkably productive when it comes to publications during her student time. So Niyati, please correct me if I'm wrong, but I think that it's something like 4 peer-reviewed conference publications, Sigmund Morphon, Elrek, Icon, and Connell during her master studies. And let me also say that Niyati comes from India, so there's a bunch of languages which are quite under-resourced in India, in spite of the huge number of speakers. So it's one of her, or it was one of her research topics. Okay, I think this is enough. Niyati, the floor is yours.
Thanks. So yeah, so I'm gonna present two works that I did at UFAL and Saarbrücken. So this one, the first one is the work that I did for my master's thesis. And yes, okay, so yeah, so as the next step, we were working with the Indic language family, and here is the tree on the right. In specific, we were looking at a dialect continuum across North India that has more than, say, 40 to 50 closely related dialects and variants. And many of these languages are spoken by more than millions of people. So there is, of course, high value in building NLP support for them. Right, so here's a zoomed in map of North India, and this is what is referred to as the Hindi belt. And we also have subfamilies, genealogical subfamilies of this language family. Right, so unfortunately, many of these languages don't have any official status in the places that they are spoken. They lack, so for example, primary education does not happen in these languages, and there are very few resources that are published, like newspapers or journals, etc., that are published in these languages. And of course, there is correspondingly a very low digital footprint. And this means that we have little or no NLP for most of them. But we do have closely related high resource languages, right? So Hindi-Marathi, Nepali, for example, are all much higher resourced and are written in the same script as most of these languages. So yes, of course, so there's sort of hope that cross-lingual transfer can benefit these dialects. So here on the right, we have 31 languages that we divide into 3 bands, depending on how many resources and how much research we have for them. And in the first band, we have these languages that I talked about, Hindi and Marathi, that are doing relatively well off. And then we have band 2 languages for which we have a few data set, and we have sort of devoted teams in India that are working on developing NLP for these languages. And then we have band 3 languages for which there is pretty much nothing. So no data sets and no research, no resources. No research. Yeah. So band 3 languages are the focus of this first work. Right, so this project was done in these 4 stages. We had to first collect raw monolingual data to work with, and that in itself was difficult because, like I said, there is not much digital footprint to these languages. And even though we can assume that people do use them when they speak online, it of course we would need some kind of sophisticated language identification tools to be able to tell which specific dialect it is, since they're all written in the same script, they have a lot of shared vocabulary, and so on. So this is the resource that we eventually used. It's a website called Kavita Kosh, and it has folk songs and poetry for these languages and dialects. And yeah, they are manually collected by the team of like the Kavita Kosh team. And yeah, that's a schematic on the right. Here is what the corpus that we collected looks like. So we have band one, the data that we collect for band one languages is not so important. Like I said, we have other resources for them. For band two languages, it is sort of comparable and good additional resource. And for band three languages, it is the only monolingual data that we have. But yeah, if you look at the tail end, we only have like say a few hundreds of tokens for a couple of these languages. Right, so this data set is available publicly for anyone to use, and we hope that people will use it. So once we have this data set, we want to do some sort of exploratory experiments to see whether, for example, lexical overlap sort of fits our expectations based on, linguistic research, right? So these are just so this heat map shows pairwise lexical overlap, and we also construct a dendrogram for these languages using this measure over here. And as you can see, this it's sort of, its lexical overlap is high for some collections of languages, and they do correspond to our genealogical subfamilies, but I will come to that in a bit. We also look at subwords because we are talking about morphologically rich languages, right? And yeah, so subwords as approximating morphemes, that is. And we look at like a similar overlap measure for subwords, and then we also weight, we find this measure for different lengths of subwords, and then we weight that measure, and we put it all together, and that's what this looks like. I mean, this is what that looks like. And we also look at some KL divergences over subword distributions. So in general, that's a lot of heat maps, but they are all roughly sort of consistent with groups of languages that are close by, and the dendrogram as well. And in general, we see that geographically closer dialects show closer sort of higher similarities, right? So the Purvanchal languages are the languages in the east, and similarly for the dendrogram, we mostly see what we would expect. We also see that the Hindi corpus has a high similarity with other languages. This can be due to a number of factors, including noise in the Hindi data set. Right, so next we want to do cognate induction for this corpus. Cognates are words that have shared origins or etymologies, and in this work we don't differentiate between cognates and borrowings. Borrowings are words that have been taken from one language into another, right? And of course the boundary is a bit fuzzy, but yeah, so like I said, these languages have a high shared vocabulary, And the reason that we would look at cognate induction as one of the first things that we want to do once we have a bunch of, monolingual corpora, is because bilingual lexicons, right, are an extremely flexible resource for anything that is related to cross-lingual transfer, especially in low resource settings. So word-to-word translation, for example, or transferring embeddings, or a lot of other stuff, right? So yeah, and about a couple of design decisions. There are a number of ways we can structure this sort of cognate lexicon building when we have a lot of languages, right? And one of the ways we can do it is to have this multilingual, or this truly multilingual setup where we sort of look for cognate relationships pairwise between every pair of languages. That is, and of course, that is an extremely resource intensive way to go about it, and we don't have those kind of resources. Instead, what we opt for is this approach here, where we have a single anchor or a single pivot language, and then each other language is has like a lexicon, bilingual lexicon with that with our anchor. In our case, our anchor is Hindi, since it is sort of the most high resource and well connected to all the other dialects. Ideally, we would also have liked to have lemmas or some linguistically motivated unit, like subword unit, like morphs or morphemes in our lexicons. But again, we don't have lemmatizers for these dialects, and we don't want to introduce further noise in the pipeline by trying to train something ourselves. Right, so this is just briefly on the approaches that people generally take to this problem. Cognate induction and detection has been studied a fair deal in historical linguistics, and people in historical linguistics would traditionally use a sort of whole host of orthography-based measures, like string distance-based measures, that is to say. We also eventually had these evolutionary approaches, or approaches that exploited this shared genealogy of languages in, for example, a generative way. This is the figure on the right. We can go into that a bit more if anyone's interested. But yeah, and finally, and more recently, we have works that frame cognate induction as machine translation, or a character level machine translation scenario. But of course, that is supervised, and yeah, we don't have any prior data that is to train such a model on. So for our baselines, we use simply edit distance. And the reason that we would think that this would be an okayish baseline is because Devanagari is orthographically shallow, which is to say that spellings of words closely represent their pronunciations. And so you would expect that, well, yeah, that's, yeah. So, and we also use a variant of this, which is called the Yarrow-Winkler metric. And the only difference is that this metric would consider differences in the beginnings of strings as more serious than differences in the ends of two strings, right? And this is sort of trying to model the stem versus inflection difference in words. Of course, there are a couple of issues, like in principle, with this baseline. Firstly, that it treats all character substitutions equally, which we might not want. For example, we might know of sound changes in pairs of dialects, and we might, and we might not want to, we might know that two characters, for example, always correspond to each other, and we might want to give them a different weight. This SOL baseline also treats all language pairs identically, which also we don't want. And finally, we don't want, and finally, this approach is purely string-based, that is, it ignores semantics. And yeah, that is a fairly serious limitation. Next, we want to try to handle the first two problems. That is, we want to try to customize this this string distance based metric, and we do that using this iterative approach. That is, we build a custom edit distance matrix for a given pair of languages in an iterative way, and that means that we, in an expectation step, for example, we would, and given this this matrix already, we would find new cognates in our two languages, and then in a maximization step, we would sort of modify our edit distance matrix to better fit our cognate list, right? So I hope that makes sense. Here we have a few details of how this is done. So what is a score that two characters have? It's simply conditional probability of when we see this transformation, as opposed to how many times we saw the source character. Yeah, and so on. Again, we can come back to this if anyone wants to. So yeah, this idea addresses first two of these limitations, but is still agnostic to word meanings. And that is what we try to look at with our next approach, which uses bilingual embeddings with the aim of sort of mitigating the effects of coincidental similarities in spellings between words, right? And so the idea of this approach would be to train bilingual embeddings, and then use these embeddings to identify semantically close by words, and then filter them by orthographic similarity, or rather not filter, but re-rank them by a combination of semantic and orthographic similarity. And this expression here is basically, that's what it's trying to say. We also try a variant of this that uses our learned edit distance matrices with the bilingual embeddings. And yeah, so I hope that makes sense. So those were our approaches. We first, of course, need evaluation data, which we don't have. And so we went once more searching on the web. We ran into, of course, the same issues, which is that, there are no published sort of materials of this kind in a standardized way. And yeah, especially because we have so many languages, we really want a resource that has, ideally a single set of words in Hindi, and then their equivalents in all of these different dialects. Here is a sort of collection of all the resources that I found. And by resources, I mean like people putting sort of translations of some words into their native language in blog posts or on language learning websites or that kind of thing. And yeah, many of them are not usable because of how small they are, or because the website is doesn't want to be used by other people. But eventually the resource or the website that we ended up using looks like this. And it's a language learning website. It has translations of simple English sentences into 20 of the languages that we're working with. And crucially, it has the same English sentences for all languages, which is really nice, because then we are sort of close to the situation where we have a single set of words in our anchor language, right? Of course, these are sentences, and we wanted lexicons, so we still have to process this raw data. And the other problem is that it's in the Latin script, which is an issue. So we have this processing pipeline. Very briefly, we clean it, we transliterate the non-English sentences, we re-parallelize them with Hindi, and then we find alignments using fast align, and then we read those alignments into a bilingual lexicon, right? And this pipeline is available on the GitHub and easily runnable by anyone who wants to. Here's what the extracted bilingual lexicons look like on the right. This is the column that you want to follow. It has the number of unique Hindi words that have equivalents in the target language, right? So some basic stats. We have the average size around 150 words. That's pretty nice. We manually tested the quality of one of them, which is Hindi and Marathi is the only other language I speak. And we found that the quality of the alignments was all right, like 73-ish%, but that the translation was quite bad, which is a shame. But nothing to do. So we know that these lexicons are fairly noisy, but yeah, we use them anyway with this knowledge. So this is what the results look like. Here is the average row, and we see that firstly we see that all performances are quite low, and secondly we see that our semantic plus orthographic method performs just a little bit better than the other approaches. The low performance is expected because of our sort of low resource scenario and the fact that we don't have any seed whatsoever, as well as the noise and the evaluation data. And yeah, we looked manually at the outputs of our different approaches to see what they were doing. And it's sort of as expected. The purely string-based approaches get sort of distracted by like coincidental spelling similarities, especially in short words. And the custom like EM at a distance matrix technique learns some useful things, but unfortunately it's quite seed and initialization dependent and needs more tuning, and a seed would be really helpful to sort of set it on the right track. And finally, the last approach that uses bilingual embeddings performs produces generally a better collection of outputs, even if that collection doesn't have the intended cognate. It's still a better it's still a better collection of outputs to have, especially when we are looking like our end result is supposed to be a lexicon, right? So we would much rather have words that are sort of semantically close by rather than orthographically similar, right? So that is right. Here are a couple of examples. They are not very useful unless you read Devanagari, but we can go through them if anyone wants. And yeah, that's a quick recap of what this was all about. Right, so this is the second work that I'm going to present that is thematically quite similar to the first one. And I did this one actually before my thesis, but it's more logical this way. So that's why I'm presenting it second. And it deals in transferring embeddings, as the title suggests. So here we have this map of India again, except now we see our Hindi belt as a monolith, which says Hindi. And we also see these other languages. All of these are high resource. There are around 14 relatively high resource languages in India. And they come from primarily two language families. That is the Indic language family, which is above this line over here. All of these are Indic. And then you have the Dravidian language family that are all of these languages, right? And these ones here that are labeled, they all have, they have sort of solid data sets and other like low-level NLP tools, for example, as well as language models and what have you. But we also have loads of other languages that are all low resource, and of course, I talked about that already. And we do have the situation where many of these low resource languages have like a high resource language that they are closely related to, and these languages share morphosyntactic and morphosyntax similarities, as well as they show patterns of sound change and so on. I've sort of already touched upon that. So looking at subwords with a bit more detail, we already know that these languages are morphologically rich, and we also notice that while they often share many morphological properties, this often happens at a sort of like the correspondences between different languages are often at a morph or a morpheme level rather than at a token level. So and tokenization conventions may be different across languages. So to illustrate what I'm saying, here is an example on the screen where we have the same concept, that is to the doer, and we have these two languages, Marathi and Hindi. And we see that Marathi expresses this concept with a single token consisting of 3 morphs, and Hindi instead uses 3 tokens, but with direct correspondence to each of the Marathi morphs, right, along with its sort of syntactic function. So this is the intuition that sort of motivated this subword level transfer, as well as morphological segmentation, that is unsupervised segmentation for both of these languages. And we'll take a look at trying to show the benefits of doing this. Right, so here's the setup of the task. We have a high resource language and a low resource language that are closely related to each other in all of these ways. And we want to find a method of transferring embeddings at a subword level. from the high resource to the low resource language. We want to use only monolingual data, which is sort of natural because we don't have parallel data for these languages. And in this paper, we worked with Hindi and Marathi, simulating a low resource scenario for Marathi because of constraints on evaluation data available. The first thing that we tried was motivated from this very simple idea, which is that if you already have good quality subword embeddings for your high resource language, and if you imagine that you could sort of find a morph to morph bilingual mapping, then why couldn't you, for example, for any low resource, for any word in the low resource language, decompose it into morphs, simply copy over the morph embedding from the high resource language and then put them back together and use that. Right. So that is the idea of this approach. And the sort of first problem is that we don't have a morph to morph bilingual mapping. In this work, we simply used normalized edit distance, and as we would later see, that is a quite strong baseline. But of course, it is only good for cognates and borrowings, right? But yeah, anyway, so that is what we did. Next, we tried something a bit more sophisticated, an iterative approach given by this work, Atech et al. 2017. It's called WetMap. It learns bilingual word embeddings, or rather, it projects monolingual embeddings into a bilingual space in an iterative manner, and in which it alternately modifies its bilingual embeddings and while learning a bilingual lexicon, right? And yeah, so this approach has been obviously tested in the original work for high resource languages on both sides, and at the word level. So our hope with attempting this was that firstly it would still work when we were with respect to morphs or subword embeddings, and secondly that with a sort of data asymmetric situation, it would serve to actually transfer the quality of the high resource language embeddings to the low resource language, right? In the sense that it would serve to sort of have, so if you have this high resource space, then to sort of put these low resource subwords into that space in a way that would benefit the low resource language, right? So yeah, so this is just the experiment setup. We used FastText that was trained on a lot of data for Hindi as an initial embeddings, and for Marathi we used less than 1 million tokens. Like with unsupervised morphological segmentation. And of course, we also do it without segmentation, but we'll see that in a bit. And for evaluation and comparison, we use also FastText embeddings, but trained on a lot more data for Marathi. Sorry, I mean, this slide doesn't have the numbers for some reason, but we are talking around 20 million tokens for Hindi, and for Marathi, I think it was 0.8 million tokens in the low resource artificial setup, and for the high resource, it was similar to the Hindi, so around 20 million or so. For evaluation methods, we used these two methods. The first one is a word similarity data set, and the idea of this evaluation task is that you have a human annotated similarity judgments between pairs of words in two languages, and then you query your embedding space with those pairs of words, and you collect those like cosine similarities, for example, and then you find correlation between these human and model judgments, and that's your measure of goodness of the embedding space. We only have this for 7 Indian languages. Yeah, and for the second evaluation method, we used word nets, which are available for 18 languages, for Indic and Dravidian. And the yeah, it's a simple idea. It's an identify the synonym task. So you have a query word, a synonym, and then some distractors, and the embedding space has to identify which of them is the synonym, right? So that's our evaluation methods. Here are the results. That's a lot of numbers, so I will point out the approaches. So with the green arrows, we have simply a baseline, which is fast text trained on raw, the low resource Marathi data without segmentation. The purple arrows point to results with simply morphological segmentation on the raw data and nothing else. So you see that already with segmenting the data, we have like a 20-point jump on the first task, and similarly quite a considerable jump on the second task as well. Next, we have our iterative approaches over here, and we see further improvements. Over here, in this row, we see the iterative approach that started out with pre-trained Hindi embeddings. And finally, with the orange arrows, we see the iterative approach, but started with Hindi embeddings that were trained on segmented Hindi text. So we see that the last idea that I mentioned, where text in both languages is segmented, does the best in both tasks, which sort of supports the initial intuition that correspondences are shared and should be transferred at the morpheme or subword level. And it's interesting to see that this outperforms using pre-trained in the embeddings, because the pre-trained in the embeddings used magnitudes of more data than we did for training our fast text on segmented text. Right. So yeah, so I think I already touched on most of these observations, but in general, models trained on segmented data do better in the monolingual setup and also in the bilingual transfer setup. Sorry, I realize I didn't mention this, but this slide doesn't have results for our for the trivial transfer approach, and that was because it did not so well. It did, like, it gave no improvement over the monolingual approach plus segmentation. So yeah, those results aren't here. Sorry, so I was saying that we see that this approach doesn't work, and we looked at that a bit more. We looked at that in a bit more detail with some experiments on what happens with identical words in these two languages, even when we copy embeddings. And the answer is that it doesn't work. Copying embeddings seems to destroy something. Like, even when the two languages are related, it seems that it's sort of better to train on even a little more lingual data than try to copy over embeddings from another language. And that's quite interesting, by the way, I found, at least. And finally, we see that the Hindi data is useful unto a certain point, but not after that. So we did try to double and half the Hindi data that we used in the iterative approach, with not much effect on the results either way. And right, so finally we replicated these experiments on Nepali. Nepali is also an Indic language. It is slightly further away from Hindi than Marathi is, or yeah, and but it also like similarly to Marathi, it's like morphologically rich and more so than Hindi, and so on. Right, so here are the results again, and I won't go into them in detail, but in general, we see the exact same trend, which is that segmentation helps, and the iterative approach does better, and segmentation with the iterative approach does the best. Right, so yeah, that's all. Now it would be useful to repeat this pipeline for truly low resource language pairs. At the point that I did this, we didn't have any bilingual lexicons to like for evaluation, but now I guess we have some bilingual lexicons from the ones that we collected for the thesis work, so this would actually be possible. And yeah, that is all. I think I finished a little early, but yeah.
Okay, thank